Welcome to the Deep Dive. Today, we're going to be diving into something I find really fascinating, JavaScript functions. Specifically, we're going to be tackling a challenge that I presented on AI.Code.Cast.
Oh, cool.
It involves creating a function that returns another function, and this second function always spits out hello world. Now, it might sound simple, but trust me, there's a lot to unpack here.
Yeah, it's a classic challenge for a reason. You know, it really gets you thinking about how JavaScript works at its core.
Right.
And we actually got a bunch of solutions from the AI.Code.Cast community.
Awesome.
And they show off some pretty elegant approaches. Each of them has their own little nuances and trade-offs, of course.
I love that. So let's set the stage for our listeners. Can you walk us through the challenge itself, and why might this be a head-scratcher for some folks?
Absolutely. So the goal is to create a function. Let's just call it create hello world for now.
Okay.
This function, it doesn't actually print hello world itself.
Okay.
Instead, its job is to produce another function.
Oh.
And it's this inner function that when you call it, it'll always return hello world, no matter what you throw at it as input.
Okay, I'm already intrigued. Now, I'm guessing that some folks might be tempted to just hard code hello world and do a simple function and just call it a day, right?
Right.
What's wrong with that approach?
Yeah.
Why does this challenge go a little deeper?
You're right. A brute force approach might seem tempting at first.
Yeah.
You could just define a function that spits out hello world directly.
Right.
But the real learning here is to understand these elegant concepts like closures,
Yeah.
higher order functions.
Right.
These are key tools for any JavaScript developer, and this challenge kind of forces you to think about them directly.
Got it. So it's not just about making the code work. It's about using the right tools for the job
Exactly.
and really understanding those deeper principles.
Yeah.
Okay. Now, before we dive into some specific solutions, what are some common pitfalls or questions that people might stumble upon with this challenge?
Oh, that's a good one. One common question is, why can't the inner function just take an argument and ignore it?
Right.
While technically you could do that, it misses the whole point of this exercise.
Yeah.
The goal is to understand how a function can just have this fixed behavior regardless of the input.
That makes sense.
Yeah.
It's about creating a function with a very specific purpose.
Exactly.
Now, I'm itching to see how these concepts
Yeah.
actually translate into code.
Yeah.
Let's start with one of the community solutions.
Okay.
Perhaps solution number 18,
Okay.
which I hear is remarkably concise.
Excellent choice. Solution 18 is a great example of just how powerful arrow functions can be in JavaScript.
Cool.
It's like, imagine defining a function, create hello world, that doesn't need any input.
Okay.
Inside that function, we create another function on the fly using an arrow function.
Okay.
And that arrow function, it doesn't take any input. It just spits out hello world.
Okay.
And then finally, our create hello world function, it returns this newly created function.
Wow, that's incredibly compact.
Yeah.
But I'm curious, how does that inner arrow function know to always return hello world without explicitly taking any input?
Right.
What's the magic behind that?
That, my friend, is the magic of closures.
Okay.
Think of it this way. That inner function, even after it's been created and returned by the outer function, by create hello world,
Yeah.
it still has this little piece of its birthplace with it.
Huh.
It's as if it's holding on to this like secret message, hello world.
Yeah.
And it's gonna faithfully deliver that message whenever it's called.
Okay, I love that analogy.
Yeah.
So the inner function isn't just some isolated code.
Right.
It has this hidden connection to its surroundings.
Exactly.
Now, are there any downsides to this super concise approach?
Well, the trade-off here is flexibility.
Okay.
Solution 18 is super elegant and it's efficient for this specific task.
Right.
It might not be the best choice if you later needed that function to do more than just spit out hello world.
Sure.
So imagine if you needed to adapt it to, like, greet someone by name.
That requires some rethinking.
That makes perfect sense. It's like having a specialized tool that's great for one job, but not so much if you need a multi-tool.
Yeah.
Now, let's switch gears a bit and look at a solution that maybe illustrates closures in a more explicit way.
Okay.
What about solution number 3?
Okay.
It uses a detective analogy, which of course always catches my attention.
Yes. Solution 3. It's a great illustration of closures, even though it may not be the shortest or most efficient solution for this problem.
Gotcha.
Imagine we have this detective. Let's call her Outer.
Okay.
And she's investigating a case. And she's holding this crucial clue, some piece of information like a name.
Yeah.
Now she calls in her partner, another function, inner.
Okay.
and shares that clue with her partner.
Right.
Even after outer leaves the scene,
Yeah.
inner still remembers that clue.
Wait a minute. So you're saying the inner function is like the detective's partner?
Yeah, holding on to that crucial piece of information even after the outer function has wrapped up its investigation.
Exactly.
Okay.
That's the essence of a closure. The inner function closes over variables from its surrounding environment.
Okay.
It's like packing a snack for a long journey. Even when you're far from home, you still have that snack with you.
That's starting to click.
Yeah.
So how does this detective analogy, this concept of closures, actually apply to our hello world problem? I'm not seeing that direct connection yet.
Well, imagine that instead of a name, the clue that outer passes to inner world is the instruction to always return hello world.
Okay.
That inner function, thanks to closures, would cling to that instruction
Okay.
and execute it faithfully every time it's called,
Yeah.
no matter what other inputs or distractions are thrown its way.
So even though solution 3 is using this detective analogy,
Yeah.
the underlying mechanism is the same as in solution 18.
Yes.
Closures are at work, allowing the inner function to remember what it's supposed to do.
Exactly.
Okay. Now, before we move on to other solutions, I'm curious, how do these two solutions compare in terms of efficiency? Is one significantly faster or more memory efficient than the other?
That's a great question. In this specific case, both solutions are very lightweight. They don't require a ton of processing power or memory. The main difference is in their style and explicitness.
Okay.
Solution 18 is incredibly concise, while Solution 3 is more verbose, but maybe it makes the closure mechanism a bit more transparent.
Got it. So it's a trade-off between elegance and clarity. Now, I'm ready to explore another approach. What about this solution that uses a traditional function declaration with REST parameters?
Oh, yeah.
It seems like a bit of a hybrid approach, combining the old and the new.
You're spot on. This solution takes a more traditional approach. It uses the familiar function keyword to define our functions, but then it throws in this modern twist with REST parameters.
Okay, I like where this is going. Can you remind me, what are REST parameters?
Yeah.
Why are they relevant here? Because it seems like they might be overkill for this challenge, since we're not really using any arguments, right?
You're right to question their necessity here, but they do have a purpose. Imagine REST parameters as a way for a function to say, hey, I'm open to receiving any number of arguments,
Okay.
but I'm not going to commit to using them right now. They
Yeah.
provide this flexibility, this future-proofing for our code.
Interesting. So it's like leaving the door open for potential changes down the road.
Exactly.
That's not about what the code's doing now, but what it could potentially do in the future.
Exactly. And from a readability standpoint, REST parameters signal to anyone reading the code
Right.
that this function could potentially handle arguments,
Yeah.
even if it's not doing so at this point in time. It's all about clarity and maintainability.
I'm starting to see the appeal of this approach. Now, can you walk us through the structure of this solution?
Okay.
How does it differ from the previous two that we just discussed?
So imagine you're building a robot. The outer function, our trusty create hello world, it's in charge of assembling the basic framework, right?
Okay.
Then it equips the robot with this special tool, the inner function.
Okay.
This inner function, it's defined using the good old-fashioned function keyword.
Right.
Armed with those REST parameters, it simply announces hello world whenever activated.
Okay, so even though we're using the traditional function declarations and these REST parameters, the core logic is still the same. The outer function creates.
Yes.
Inner function returns hello world.
Returns hello world, exactly.
It's all about the separation of concerns.
You got it. It's like having a dedicated team for each part of the process. One team builds the structure, another team focuses on the specific task at hand.
Now, while this solution is clean and modular,
Yeah.
how do you think it compares to the previous ones in terms of performance?
That's another good one. Since we're essentially doing the same thing, just with slightly different syntax, I wouldn't anticipate a huge difference in terms of speed or memory usage. How about you?
I'd agree with that.
Yeah.
All three solutions are pretty lightweight in terms of performance. The choice often comes down to personal preference,
Exactly.
coding style, and the specific needs of the project.
Right.
All right, that's fantastic. We've now seen three distinct approaches to this challenge,
Yeah.
each highlighting different aspects of JavaScript functions.
Right.
Before we wrap up this part of our deep dive, what are some key takeaways that you want our listeners to ponder?
I think the biggest takeaway here is that there's rarely a single right way to solve a coding problem.
Sure.
Understanding the underlying concepts and the trade-offs is crucial
For sure.
for choosing the best approach for a given situation.
That's such a valuable insight. It's not just about memorizing syntax. It's about understanding the tools that we have in our toolbox and knowing when to use each one. Now, in part 2 of our deep dive, we'll explore how these seemingly simple solutions actually connect to real-world coding scenarios. Stay tuned to uncover the hidden power of these JavaScript concepts.
I can't wait. Welcome back to the deep dive. In part 1, we took a deep dive into the fascinating world of JavaScript functions. Specifically, we tackled the Hello World challenge from AI.Code.Cast. Now, let's shift gears a little bit and see how these simple concepts, they actually manifest themselves in real-world coding scenarios.
Yeah, I'm all ears. It's always exciting to see those theoretical concepts come to life in practical applications.
Absolutely. So let's revisit the concept of closures for a moment. Remember how our inner function could remember information from its outer function?
Right, like that detective's partner holding onto that clue.
Exactly.
And I'm starting to see how that could be useful, beyond just printing hello world.
Absolutely. Closures are incredibly powerful for managing state and creating reusable logic in our code.
Okay.
So let me give you a concrete example. Imagine you're building a simple counter on a website.
Okay, yeah.
Each time a button is clicked, the counter increments by 1.
Okay, I can picture that.
Now, a naive approach would be to use a global variable to store the counter's value.
Right.
But this can lead to all sorts of problems, especially as your application grows and you have multiple scripts that might be interacting with that same variable.
Yeah, I see. So using a global variable could create conflicts and just make the code harder to maintain.
Exactly. And that's where closures come in.
Okay.
We can use a closure to kind of encapsulate that counter's value
Right.
and protect it from outside interference.
Oh, okay, cool.
So let's imagine creating a function called createCounter.
Okay.
Inside this function, we initialize a variable, let's call it count. We set it to 0 initially. Yeah. Then we define another function, increment, which increases the count by 1 and then returns that updated value.
Right.
Finally, createCounter returns this increment function.
Okay. So increment is our inner function, and it has access to that count variable even after createCounter has finished running.
Precisely. Thanks to the closure, increment carries a reference to count.
Right.
This means each time we call the increment function that was returned by createCounter,
Right.
it updates its own private copy of count without messing with any other part of our application.
That's brilliant. So closures provide a way to create these isolated pockets of state in our code, keeping things organized and preventing all of those unintended consequences.
Exactly. And this is just one example. Closures are used extensively in JavaScript frameworks like React to manage component state, handle events.
Right.
They're like the backbone of many complex interactions you see on the web.
Okay, my mind is officially blown. I never realized how fundamental closures are to modern web development.
It's all about layering, right? You start with this simple concept like our Hello World challenge,
Right.
and then we see how that same concept scales up to build these complex interactive systems.
Speaking of scaling up, let's talk about higher order functions for a bit. Our create hello world function was a prime example of a higher order function because it returned another function.
Yeah.
How does that translate into these real world scenarios?
Higher order functions are all about abstraction and reusability.
Okay.
They let us create generic functions that can operate on other functions,
Right.
making our code more flexible and expressive. Think of it like having a set of Lego blocks.
Okay.
You can assemble them in countless different ways.
Yeah. That's a good analogy.
Yeah.
Can you give me like a concrete example of how higher order functions are used in practice?
Absolutely. So let's say you have a list of numbers and you want to do some operation to each of those numbers, like
Okay.
squaring it or doubling it.
Okay, yeah.
Now, instead of writing separate functions for each operation, you could use a higher order function like map.
So map would be our higher order function in this case.
Yes, exactly. Map takes 2 arguments, the list of numbers and another function that defines the operation we want to perform.
Okay.
Map then applies that operation to every number in the list and returns a new list with the results.
Ah, okay, cool. So the magic is that we can pass different functions to map to achieve different outcomes without having to write repetitive code.
Exactly. That's the beauty of higher order functions. They provide this level of abstraction
Yeah.
that makes our code more concise, readable, and adaptable over time.
I'm starting to appreciate the elegance of that approach. Now, before we move on, I want to revisit the solution that used the REST parameters for a second. You mentioned they were about future-proofing and clarity, even though we weren't really using any arguments in that hello world example.
You're right to bring that up. REST parameters may seem a little bit overkill in our simple challenge. They
Okay.
become super valuable in those real-world projects. Imagine building a function that needs to be flexible enough to handle different numbers of arguments in the future. Right.
Yeah.
REST parameters allow us to do that gracefully, without rewriting the entire function.
So it's kind of like building a house with extra rooms, just in case you need them down the line.
Precisely. It's about anticipating those potential needs and designing our code to be adaptable.
Okay, this is all great advice. I'm starting to see how even the seemingly trivial details of our Hello World challenge have these broader implications for writing robust and maintainable code.
It's all connected,
Yeah.
and that brings us to another crucial point. The balance between conciseness and clarity. Remember, we saw that with our arrow function solution, which was super compact, versus the more explicit solution using the traditional functions.
Right. Sometimes the most elegant solution isn't the easiest to understand, especially for someone who's new to that code base.
Mm-hmm.
It's a trade-off, right?
Absolutely. Finding the right balance really depends on the context. In a small, self-contained function, conciseness might be preferable,
Yeah.
but in a large, complex system, readability and maintainability become paramount. And this leads us perfectly into part 3, where we're going to wrap up with our key takeaways and leave you with a thought-provoking question to ponder.
Welcome back to the deep dive for the final part of our exploration of JavaScript functions. We've been breaking down a classic coding challenge from AI.Code.Cast, and we found some pretty powerful concepts along the way.
Yeah, it's been quite the journey. From those super concise arrow functions to those, illustrative traditional functions with REST parameters, we've seen how a seemingly simple problem, like creating a function that just spits out hello world, can actually teach us so much about how JavaScript works under the hood.
It really is amazing how much depth we've uncovered. So for our listeners who've joined us along this journey, can we recap those key takeaways from our deep dive?
Absolutely. I think the biggest takeaway is that, it's not just about getting the code to work, it's about understanding the why behind the code.
Right.
We looked at different solutions to the Hello World challenge.
Yeah.
And each of them kind of highlighted these different JavaScript concepts and the trade-offs involved.
Exactly. It's not about just memorizing the syntax. It's about actually grasping the underlying principles like closures, higher order functions, and that balance between conciseness and clarity.
Yeah, exactly. And these principles go way beyond this one specific challenge.
For sure.
They're the foundation of writing elegant, efficient, maintainable JavaScript code,
Right.
no matter the project or the complexity of the project.
I feel like we've been given a new lens through which to view JavaScript code.
Yeah, that's a great way to put it. And the best way to master this new perspective is to just keep practicing, keep experimenting, and always ask why.
Curiosity is key. Now, before we wrap things up, I have a final thought-provoking question for our listeners out there. We've seen how to create a function that always spits out hello world no matter what the input is. But what if we wanted to make it more dynamic? What if we wanted that output to change based on some input, like a name? How could our listeners adapt the solutions we talked about to achieve that?
That's a fantastic question, and I'm going to leave that for our listeners to explore on their own. It's a great way to test your understanding of closures, function parameters, and just the overall flexibility of JavaScript functions. We encourage you to experiment, share your solutions with the AI.Code.Cast community, and see what creative solutions you can come up with.
Awesome. I love a good challenge. So to our listeners, we encourage you to keep coding, keep learning, and keep that spark of curiosity alive. Remember that the journey of exploration is just as rewarding as the destination.
Happy coding, everyone! Until next time on The Deep Dive.